Hi there, this is session 7 of programming from the very basics using Python. In this session, I will delve a little more deeper into converting between data types. I will get a little more details into it, and I'll also cover the print function in this session. So, in the last session, I taught you about how you can take in string input from a user and convert it to floating point. You can convert most data types using the type constructor expressions like I showed you for float. For example, if at all I have a is equal to 10 and I told you that a is an integer, you can always convert it to float by using the float constructor by using float of a. And then when you look at b here, b is a floating point like you can see in this output. You can see that 10, which was supposed to be an integer represented through the variable a, I was able to construct a float out of that integer by using the float constructor expression, right? As you can see here. And b is obviously a floating point output and the class is float. We can also do the reverse of it, where you can always create an integer from any other compatible types. For example, if I have a is equal to 5.4, 5.4, which is a floating point. We all know that, right? I can say print a and type of a, it's float this time. Now, if I say b is equal to int of a, try to print b and type of b, you could see that this is converted to an integer. Now, if you're trying to convert a floating point to an integer, I guess you know that you get the floor value, which means that only the integral part of the float is retained. The decimal part is completely truncated. Some of you might think, what if the value is like 5.9, 5.9? Even now, you can see the result is always the integral part. The floating point precision is lost. There are times where you want to round off a floating point, rounding it off. Round off is a mathematical function, which means if the value is 5.5 and 5 point, below 5.5, it's below 0.5, right? You want to floor it to 5. Because 5.5 or above, you want to round it to 6. So if you want to do something like that, then there's a built-in function called round function. So if at all I have a value, let's say a is equal to 5.4, this time I'll say b is equal to round of a, and I'll write print b type of b as usual. You can see that it's shown up as an integer. The value is 5. It's very similar to int construct here. But when you actually make the value as 5.6, for example, you can see that value is actually rounded up to the next higher value. Even if you try 5.5, I guess it should be the same, right? So if it's 5.5 or above, it's transformed to a value 6 when it's converted to integer. But when the value is below 5.5, it's like 5.0 to 5.4, will be treated as 5. So you can round off to the next integer, the floor or the ceiling value based on this round function. A couple of you are mathematically inclined might ask me, oh, is there a ceil function or is there a floor function specifically? Well, it's not a built-in apparently. So ceil is available in a math module, but this round is available as a built-in function at this moment. Round also has another use case. It's possible that you can actually specify the round off to floating points. For example, if at all I have a floating point value which has got more decimal digits, let's say a is equal to 2.345678, right? So this is a floating point value. We can just try to print it here. You might want to round it off to 2 decimal points. You want to remove all these extra decimal points. I want to round it off to the 2 decimal points. Then you can actually try this out. You can say b is equal to round of a and pass an optional second argument 2. So how many decimal points you want to round it by. This time the result is a float, but it's rounded to the 2 decimal points. You can see that because you have 2.345, the value is 5 here. So it's made as 2.35. It's rounded off to that number. If the value was like say 2.344, for example, you can see what value we get here, 2.34. So round has two functionalities. One, if you pass just one single argument, assuming the argument is a floating point, it will round it out to the next integer. But by passing a second argument, you can round it out to that many decimal points. So you can say it's 2 decimal points, or you can actually use, let's say, 1 decimal point if you want to. And this would work, right? This is a built-in function useful for converting from float to integers, or rounding off floating point values to fewer decimal points. And this is one feature. And I should tell you that you can also create an integer from a string. And this is something more interesting. Not many people might be aware of this. And it's quite useful. I'll talk about that. If I say a is equal to, if at all I pass a string here, which is made up of numbers, if I just type, let's say 1, 2, 3, for example, this is a string. Obviously, you cannot do any math on it. You cannot apply any arithmetic on this string object. We all learned that strings do not support arithmetic operators, right? If you want to do things like addition, subtraction, or multiplication, you have to transform the string to a number. In this case, maybe I want to convert to integer. In case you want to convert this string to integer, you can try doing b is equal to int of it. It's pretty straightforward. And if you try to say print b, type of b, you can see that b now represents the integer equivalent of that string. So integer workaround, right? So it just constructs a new integer from the existing string data. That's what I meant. Now, if at all I want to convert a string that is not made up of decimal digits, it's made up of, let's say, hexadecimal digits. I can show you here. Suppose if I try to use 0xFFAB. So here is a string that's got a hexadecimal value. Maybe I'll make it even smaller. Maybe I have something that's can easily recognize, let's say FF. The last one of the sessions I told you FF is 255, right, in decimal. But if you try to convert this string to an integer, it'll fail. And the reason is because by default, the int constructor, if you pass an argument that's a string, the string is assumed to be representing numbers in base 10. So a string should only contain digits 0 to 9. I'll use base 10 representation of that integer and use that for conversion. It creates an integer assuming that a string is having a base 10 representation of a number. But we all know it's hexadecimal. So how do we convert it using hexadecimal format? Well, the int construct has an optional second parameter, where you can represent the base. So the base by default is 10, but if you want to make it like, say, base 16, you can try 16 in here. So it uses base 16 conversion. You can see that 0xFF in decimal is apparently 255. If at all you want to try out something like, say, 0xF, you can see the outcome. It's 15. It's like 0 to 9. After that, you have A, B, C, D, E, F. That's like 9 plus up to F is like 15, right? And if you convert it to decimal format. You can also convert from binary number system. Suppose if at all I have a number that's in binary, I say A is equal to 0. It's a string, let's assume. It's a string. I don't need the prefix. Even here, the prefix is not compulsory. Even if you don't have the 0x prefix, it'll still work, okay? You don't need the 0x prefix here. You can just try F, it's going to convert. Or say maybe FFAB or something like that, it'll convert. But let's say you have binary numbers, and the binary numbers are just ones and zeros. Maybe I have 1, 0, 1, 1. Now I want to treat this as a string holding a value in binary number system and create an integer out of it, so that I can do some arithmetic on it. Then I can actually try this. I can say print. I can just say type b is equal to int of a comma 2. It works. I guess you know that 1011 in binary is 11 in decimal. 1010 is 10. Sort of remember it. So if you know about the binary number system, I think it's pretty straightforward. For those of you who find all these 4-bit binary numbers are difficult, you can try something very simple. Let's say 100. What do you think it is? It's 8. You can look at this like 2 power 0, 2 power 1, 2 power 2, 2 power 3 alone is available. So 2 power 3 is 8. So that's an easy way to find out. So you can check it up. It is 8 indeed. So you can always convert using different base system if you're constructing an integer from a string. You can also work with octal. You can try all numbers. A quick, what do you say, an offline exercise for you is try and find out what's the maximum base conversion that is supported. It's great. It's a nice exercise. Will it stop at 16? What about 20? What about 100? What about 500? Just try out what is the maximum base and let me know in the comments. You can just post it on comments and tell me what's the max base that you can pass as a second parameter. What's the maximum value you can pass second parameter for base conversion? If you find out the answer, try and find out why that specific number. That could be a good, interesting exploration for you. All right. So this is one of the interesting features of int, and this is very useful. I'll tell you why. Because when you do things like automation, when you are processing data, it's about automation mainly. Let's consider one use case example is in my trainings I've delivered to a couple of companies. Many of these companies, they have developers who work with logs, mostly kernel logs or some application logs, system program logs, rather, not application, system programming logs, where all these memory addresses, which are, they're on the logs, maybe some crash dump logs, which have got some memory addresses. And these memory addresses are printed in the logs in hexadecimal format. And they might want to extract that from the logs. They do file IO and extract that. But now they want to do some bitwise operations and say what is like, say, 4 bytes off from that number or 2 bytes before the number or something, and find out what is located there and things like that. So for performing this kind of bitwise operations or arithmetic operations, whatever data they read in log, which is hexadecimal, is a string, they had to use this technique to convert it to an integer so they can apply arithmetic and bitwise operations. It's one of the use cases, right? So you find a lot of interesting use cases like this. As you can see here, you can always convert from integer to float, float to integer, string to integer, and string to float. You can always convert any object to a string by using a type constructor called str. Str is quite interesting. When it comes to creating integer, you can't just convert any data type to integer. There are some data types, it will still refuse to work. All the numerics I'm talking about. Let's try, maybe I have see if I have true, okay? Let's try this. If I say int of a, true is 1. This works because Boolean is also a number. So all numbers can be interconverted. You can always construct one number from another number. One type of number from another type of number. You can always construct a float from integer, integer from float, or even complex numbers, you can work with that. But even strings, as long as they have digits, right? Valid numerical format, if as their value, you can always create a float or an integer. With integer, you can also use the base as a second parameter if necessary. I forgot to mention one thing when I talk about base. Last thing, sorry about this. I'll digress a bit. Sometimes you don't know the base. You want Python to automatically detect it. For example, if I say a is equal to 0x, it's a string. Let's say 0x 1f0. B is equal to 0 small o 645, and C is equal to, I have 0b 101. So if you have a string with these base prefixes intact, then you can always use it like this. You can try to print like this. You can say int of a comma 0. Just pass the second argument as 0. Int of b comma 0 and int of c comma 0. If you pass the second parameter as 0, I think this is supported from Python 3.8 or 3.9. It's a quite recent feature, so I need to confirm that by looking up the Python documentation. Yeah, it's a recent feature in Python. It's there in the last couple of years, right? If you use a quite old version of Python like 3.6 or 3.4, I'm not sure this feature works. So you need to verify that. What I'm trying to say is that if your second parameter as a base, if you leave it as 0, as long as the string has got the base prefixes in there, Python will automatically detect what kind of base conversion to use. If it sees a prefix as 0x, it knows it has to treat the rest of these digits as hexadecimal. If it sees a 0o, it knows that it has to treat as octal. And if it sees a 0b, it knows that it has to treat that as a binary number and apply those conversions accordingly, right? So it's something that you should know about when it comes to the second parameter for the int constructor. When it comes to the string constructor, you can construct a string from just about any object. See, with int, you cannot work with all objects. Let's take an example. Let's say a is equal to true worked. Let's try a is equal to none and try to say int of a. What do you think is the answer? Let's try it. Whoops, there's an error. You can see that it says type error. Int argument must be a string, a byte-like object, or a real number, not none type. So int, float, complex construct, or even all these basic integer or numeric types, right? They have limitations on what kind of objects they can be passed as an argument. You just can't convert anything to an integer. For example, if you pass a tuple, suppose I have a tuple here. Let's say a is equal to 10, 20. I told you when you have comma separated arguments, the right hand side, it always creates a tuple. Last session I talked about that. So if you look at a and type of a, you can see that it showed up in parentheses here and it shows class tuple. If you want to create an integer of it, let's try. I'll say maybe b is equal to int of a. It'll fail. As you can see here, it shows type error. Again, same message. Int argument must be a string, a bytes-like object, or real number, not a tuple. So there's a limited subset of data types that are compatible with int constructor and float constructor. The int and float will take a small subset. Mostly there must be numbers, some kind of numbers, or it can be a string which has numerical values in them. Only then they work. If you pass any other arbitrary types, they fail. But that's not the case with bool constructor, and string constructor. Okay, first I'll talk about string constructor, then talk about bool. If I have a number like 10 here, I say print type of a, and a, obviously, the type of a is class integer, and the value, as you all know, it's 10. If I try this, b is equal to str of a. Str is a string class. Str is a name of a string data type. Just like int and float, string also is a data type. So str is the name of the data type. So you can always use str, construct a new string by calling it, passing any argument. Whatever argument you pass to str construct, it's not going to fail. Almost every single Python object would work with this. No Python object will ever complain and say, oh, I'm not compatible. It never happens. So you can see this. You can try B. Again, maybe you can say type of B this time, and B. You can always convert any object to a string. Rather than using the word convert, I would rather say represent. That's the right way to put it. Every single object in Python has a string representation. And when you call str of that object, it's like the string constructor would internally query that object and ask, as a string, what are you? And the object will report itself as a string, I am 10. Okay, that's what you see here. Or some objects will say, I am 10.5, floating point, right? So different objects will represent themselves differently as a string. So for example, what about a tuple? Where I say t is equal to 10, 20, 30. Now, if at all I try to say maybe, s is equal to str of t and try to print s and type of s. Well, when you try to print s, it shows like the same tuple, right? It shows a tuple like this, but it shows it's a class str. Actually, instead of using print, if you just put this in a REPL right away, s as is, it shows that in quotes. Do you see that? This whole thing is in quotes. It's like when you pass a tuple to a string constructor, the string constructor would like query the tuple and ask, as a string, what are you? A tuple object will report itself as a string, I am, open parenthesis, string representation of first item, comma, string representation of second item, comma, string representation of third item, comma, and so on till the end, and close parenthesis. So every object will report itself in their own form when you pass them to a string constructor. That's called string representation of an object. Reality, the print function, you can pass any argument. Argument can be of any data type, any object, and it'll happily work. You know what the print function does? The print function internally calls str of s, str of type of s, str of every single argument you pass. It's going to get the string representation of each argument and print it as a string. That's what print does. What does print do? Print gets the string representation of every argument passed to it and prints them one by one, separated by space by default, right? So that's what you see here. So the realistic example, or not an example, I would say an analogy, a real world analogy for this would be every object has a string representation in real world, isn't it? So if I show you some object, what object do I have with me? Okay, mouse. Okay. Ask you what is this? You say it's a mouse, right? It's a mouse. The word mouse is a string. The word mouse is a string. I can have a label attached to it and say it's a mouse. Again, that's an identifier that has a string in it. But we can ask, what is this? You say, it's a mouse. Or if I ask, who are you? How do you report yourself? How do you introduce yourself? If you ask me, who are you? If you ask me that question, I say I'm Chandrasekhar, whatever my name. That name is a string representation of me. Or different people might have different string representation. For example, if you ask, who are you? I'm a rich man, I'm so-and-so. Or I'm saying, I'm the president, right? Or you might talk about your role, right? So each one might have their own string representation. And again, the funny part in Python is that there are two kinds of string representation in Python. We have the official and unofficial string representation. The str is the unofficial or a casual string representation of an object. And that's what print uses. When you pass arguments to print gets a casual string representation for every object and prints them. Many objects, the casual and official representations are the same. But for some objects, they are actually different. There are very few objects I can immediately think of. But yeah, you can see there will be some differences. Let me see if I can try this out on this REPL. Suppose if I just try to, let's say t is equal to type, I'll just take some type, data type. Okay, so I'll just say a is equal to 100 and say t is equal to type of a. You know what I'm trying to do here? Type is a construct. When you pass an argument to it, it returns the type of that object. And the type of the object is not referred to through an identifier because type is also an object. I know it's like too redundant and recursive, right? You have a type of an object and the type itself is an object. Okay, so I got a reference to the type of an object. And here, when I try to type str of t, give me the string representation of t. You see it shows up as a string here, like this. This is a casual representation. That's what print uses. Let's try another one. You also have repr of t. Oh, repr also shows up the same answer in this case. Okay, I thought it's going to do differently because looks like this Jupyter notebook is doing something else instead of repr, because when I put t here, it just shows int here, right? I was expecting that, but it didn't happen. So I need to think of some more examples, but I'll think about it later. I'll talk about modules and you'll see the differences, right? But yeah, you should just know that there's an official and unofficial string representation of many objects. For most objects which are built-in data types, especially, the official and unofficial representation are the same. But in some objects, especially when you're dealing with frameworks, any libraries, they might be a little different, right? That's one thing you should know about. The analog for official and unofficial names are like, I have my unofficial name. I say, who are you? As a casual person, I say, I'm Chandra. I can't use that kind of a name when I go to, any kind of an official setting, maybe walk into a passport office or any kind of government offices. I can't just introduce myself with my short name. I have to give my full name as per my official records. So we all have our own official names, but we are always sometimes known with our casual names, nicknames, and short names, right? That's the same way we have two kinds of string representation for objects in Python. So every object has a string representation. When you're dealing with data type, the string representation of most objects that represent data would be similar to the Python syntax, literal syntax to create them. What I mean to say is that if at all I try to use a is equal to 100, str of a, it shows 100 as a string. You know what it means? I was able to construct this object by putting 100 in here, am I right? I can recreate this object by using this string. By copying the string as a literal notation, I can recreate the object. Let's look at some sophisticated objects like, say, collections, like list or a tuple or a set. Let's take a list for a change this time. If I just try maybe values is equal to open square bracket, and I'm going to put some numbers. This list and tuple and set and dictionaries, they are heterogeneous collections. It's a D2, it's a digression. Sorry. So far I've been using only numbers, right? Some of you might have this doubt. You might think, oh, can I not have anything else other than numbers in here? Can I have like first item as a number, second item as a string, third item as another list perhaps? You can. So it's like when I say a collection is homogeneous, it's like, oh, where's my other pen box? Okay, I think I missed it somewhere. All right, missing. All right, never mind. I got this. This is a homogeneous collection. So what do you see here, right? It's a homogeneous collection. All of these pens belong to the same class. I mean, these are all like, what are these? I don't know. It's my daughter's. Okay. So anyways, it's some kind of a marker, right? Yeah, it's a marker. Yeah, it's a marker pen. Anyways, highlighters. Yeah, I was thinking the right word for this. Highlighters. So you have highlighters of different colors. All of these are objects. Maybe the objects' attributes are different because they are having different colors, but they all belong to the same class. So I have a collection of numbers like this. They are very similar to this kind of collection like this. But a collection can be fully heterogeneous, like what I have here. Sorry. Oops. Okay. Yeah. Yeah, I know this is my pencil box or whatever this is. I keep a lot of craft here. I've got a scissor. There is a pen. There's a box cutter and there's a screwdriver, by the way. I use it. And a line tester and all kinds of stuff. Tweezer. So you have a collection here. This is a collection of different objects. So this is heterogeneous. It's also unordered, by the way, right? It's heterogeneous and unordered. But you can have a heterogeneous collection which is ordered if you want to, right? It's possible. So it means that when I say heterogeneous collections, that means the items of the collections might not be of the same type. It can be of different types. For example, in a list here, I can have first value is an integer, second value can be a float, the third value can be a string, a fourth value can be something like none. It's okay to have that. Or you could also have another list inside it with something else. Even a tuple can be constructed the same way. The only difference is that you don't need the square brackets, right? So if I just show you what values is this time and type of values, it is a list. If I copy this, if you want to create a tuple, you don't need the parenthesis on the other side. Now it's a tuple. You can see it shows class tuple. It shows up as a tuple. And yeah, the parenthesis is not compulsory for a tuple as long as there is no syntax ambiguity. I'm going to show you something interesting over here where you need parenthesis. So sometimes some people ask me, oh, if I want to create a tuple, should I not use parenthesis like this? It's okay to have parenthesis. But in this case, even if you don't use the parenthesis, it'll just work fine. No difference, right? Whether you use parentheses or not, the outcome is same. It just creates a tuple. But if I have some expressions out of which I need to create a tuple, let's try this, maybe into 3. This will still work. In this case, what I'm trying to say is that create a tuple with first item as 10, second item is 20, third item is 30 into 3. The result of this expression, right? You can see here 30 into 3 is 90, and you can see here it create a tuple where the third item is 90. But if I use a parenthesis here and close the parenthesis in here, you can see the scoping is changed. The order of precedence is changed. Create a tuple 10, 20, 30, repeat it 3 times. That multiply operator will repeat a tuple 3 times. We'll learn more about that when I formally introduce it to sequence operations. But for now, you can see that you can repeat all sequences by using one operand as a sequence, and the second operand could be an integer. So it's tuple, the items are repeated 3 times. You can do it even for a list, it'll work. The same thing, right? You need a parenthesis and tuple when you're using them as a part of an expression like this. Otherwise, you don't really need to worry about having a tuple, right? Having the parenthesis around the tuple. When it comes to a list here, as I told you, it's all heterogeneous, right? You can see a 12 and you can see 5.5 and hello. But when you print this, you can see how it comes up. I mean, it's a tuple, by the way. List, here it is list. When you print this, it shows up this way. You know why? Because print internally calls str of values. So it's like when you call str of this particular object, the list object report itself as I am square bracket, string representation of first item, string representation of second item, string representation of third item, all separated by commas till the end and close square bracket. That's how it's reported as a string. And you can see that the outcome of this is that this looks exactly like the Python literal syntax. I mean, it's the Python literal syntax to recreate the list. I can just copy this, put it back in here, run this, I can recreate the list. So almost all the built-in data types in Python follow this form. So the string representation of all the objects of the built-in data types show up as if, show up in a way that you can reuse them for, you can reuse that output for constructing them literally, right? So if at all I show 10 as a string, it shows 10 as a string. So you can actually copy that literally and recreate that number, right? That's how it is. Anyways, so this is something you should know about creating strings from just about any objects. But there are some objects which are not classified as data types. They show up a little differently. And the most common convention they show up in Python, it's not a rule, it's a convention being followed, is they show up with angular brackets like this. Do you see this? When I say type of values, type represents a type object. Type is not a data type. Using types, you can create data type, but type is a type of other types. Okay, so it's like it's a meta class, you call them in object orientation. You call them meta class. It's a class of a class. It's like some people ask me what is a meta class. It's too early to talk about this, but just give you an example. If at all I ask you, if at all I say maybe, what is this? If at all I want to represent this building where I'm staying, right? This building. There should be a class for this building, right? There's a class for this building. And there's a class. Yes, there is. You say it's a building class. But how do you get the specifications of the building? You get to know the class definition. The class definition would be the building documents. If I had the building documents for this building, maybe the property documents, you can call it, I can get to know how many rooms are there and who is the owner of the building and all the other details, which is used in all kinds of government classification and stuff, right? The building or the property documents, you call them. In India, that's how it's named. You might have different things, sale deed and stuff like that, right? So that is like a classification or a class to represent this instance where I live, the building. You can also have an application or a resume for an applicant for a job, which is like sort of classifying that person's job profile. I'm trying to look at multiple applicants for a particular job. What do? I get different applications or resume from people, and those resume are like a classification that classifies who that person is and gives you all the details for it. Now, these classes classify different entities. But you know what? These are a piece of paper, isn't it? A piece of paper. So the meta class for these is paper. Get my point? Or maybe another example. Another example I can think of meta classes. You can see that this belongs to a class called highlighter. You can say it's a kind of a pen, right? To me, it's all a pen. It's got a tip. Anyways, there's a highlighter. It belongs to that class. It's an object that belongs to a class called highlighter. And this object belongs to a class called mouse. There's no relation between them. But this is made up of plastic. So is this. Both are made up of plastic, isn't it? I mean, largely, I would say. Some people might argue and say, oh, there's something else inside. But I'm talking about the cover, the shell. Largely plastic. This also is plastic, ultimately. That's what I see it as. So that's a meta class. Using plastic, I can create a water bottle. I can create a mouse enclosure. I can create an enclosure for this. So using a meta class called plastic, I can create different classes. And using those classes, we have different instances. These are the real instances of those class called, highlighter and mouse. But ultimately, they're all also made up of plastic, right? They're all made up of plastic. So the meta classes add this kind of a, classification where you can create a class for a class, right? Anyways, I'll go more deeper about it when I talk about it in object-oriented programming in Python, which will be after this particular video series, right? Anyways, so a type is more like a meta class. It returns a type, which is a meta class. And whenever you're trying to print this, it shows what type it is. It says class tuple, right? And you can also look at other things like, say, function. If I try to say print is an identifier, I told you that. So print is merely identifying a built-in function. I talked about that in the earlier session. Try this out. If I say print, you can see it shows an angular bracket here. Less than function print, blah, 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 and it shows it over here. So these are not objects that represent data, but these are objects that do something else. They're meant for something else. And such objects that don't merely represent data, by convention in Python, when you try to get the string representation of them, they show up in angular bracket. They say it's a class, they say it's a module, they would say it's a function, built-in function or method, and different other forms as such, right? So that's what you should know. So this is what you should know about type construction, and you can construct any data type or any types using the constructor expression. This can also work with tuples or list or dictionaries. Suppose if at all I have a tuple like this, print t, type of t, it's a tuple. In case you want to convert a tuple to a list, you can always do this. You can actually try v is equal to list of t. List is a type, name of the data type that corresponds to list class. So yeah, you can use that just like you use int and float. So you can try to say print v now, and you can see it shows up in square brackets, and you look at type of v, it will be a list. You can always create a list from a tuple. You can always create a list from an existing tuple, or you can also create a tuple from an existing list. So you can actually do this on the reverse. You can actually try maybe, r is equal to create a new tuple from a list, which is v. And if you try to print back r, it looks exactly like t. I got back the tuple. You can do likewise with set. You can always create a set from a tuple, set from a list from a set, list from vice versa. But you cannot transform across the board like integers, right? You cannot create a tuple from an integer. Try this out, it'll fail. String constructor is the only exclusion, the only exception where you can construct a string from just about anything. But these types, they require some other compatible types. They work with some compatible types, not all of them, right? For example, if I'll say a is equal to 10, can I create a tuple from it? Can I try to say tuple of a? It'll throw a vague error here. It shows type error. It shows int object is not iterable. Strange, right? It says int object is not iterable. What does iterable mean? I'll talk about that when I talk about the for loop. That's a detailed session where I go talking about the iteration protocol or iteration protocol, iterables and iterators. I'll discuss that in great depth. For constructing a tuple, the argument must be an iterable object. What is an iterable object? An iterable object is an object that you can iterate over, get one item at a time. Normally, you do that with a for loop. You can use for construct. You can actually say, get me the first element, second element, third element, fourth element. So I can keep getting elements across till the end. So such kind of objects, you can always create a tuple from them, right? So it must be an iterable object. So it can be any object, not just any other collection, as long as it can be iterated over. So that's something you should know about the tuple constructor, right? Anyway, so I talked about how you can construct various types. So you can think of all the built-in types. There are names for them that represent the identifier for the type. So you can see int, there's an int constructor, float, float constructor, complex, complex constructor. You have bool, bool constructor, str, bytes, byte array, list, tuple, set, dictionary. So all of these data types are like built-in identifiers in Python, using which you can construct objects of those types. Okay, so I talked about all these type conversions and type construction. Now let's talk about the print function now. So just let me just have a look at the time. Just trying to see how long I have. Okay, I do have enough time. Okay, so talking about the print function, we can see that when I say print, print can take multiple arguments. You can say print of 10, comma, 20, comma, 30. Remember, the spacing is optional. I'm using spaces here, right? It's for the tidiness. If you don't really need, you can avoid the spaces if you wish to, but it looks a little clumsy in my opinion. That's why I always prefer using spaces. But I want to show you the output. You can always see that when you pass multiple arguments to print separated by comma, each argument is printed in its string form, in the string notation, separated by a space. Do you see a space separation between that? It's not got to do with any spacing here. Some of you might ask, what if I put more spaces here and something like that? It doesn't matter. Still, you just see one space. So print by default, print each argument passed to it in its string form, separated by a space. That's a default behavior. And at the end, it also adds a new line. Two things. There's a field separator. Each of these are like fields. There's first field, second field, third field this time. So each field is separated with a field separator. And after print, think of it like a record separator. It adds a new line. We don't see that new line as obvious in here until you use another print function below. So for example, if at all I always like to keep it organized like this. Follow this as a good practice, right? If I use another print statement here and I just try to say test string for 5.6, you can use arguments of different types. It'll just work, not a problem. And you can say maybe false and 34, whatever that is. Now, as you can see that each argument that you pass is separated with a space. But you can also see that this particular string, this entire output of print, the output of print is printed on the next line, right? It's printed on the next line. It's not in the same line. The reason is because this print has added a new line. So the second print starts continuing from the next line. You can control this. There are often times where you want to tell print, oh, don't separate each of these arguments by spaces. Then all you need to do is, I'll just copy this set, okay? So you can see all the variations. I can try by passing sep is equal to empty string. When I try sep is equal to empty string, the sep is equal to this kind of a syntax grammar that you see. Sometimes some functions, when you pass arguments, you might need to pass them as keyword arguments. This kind of a syntax grammar is called as calling a function with keyword arguments. These are called as positional arguments because these are arguments by position. First argument, second argument, third argument. Whereas this is a keyword argument. And now you can just see. Let's see what happened. They're all like joined up together. They look like they're all concatenated in the output, right? There's no separation at all between each of these items being printed. You can also add a separator, which is maybe a comma space like this. Or you could use anything you want. Maybe you like to have a new line. For new line, you can put a backslash small n. This is directly taken off from C. This is called a C style backslash escape sequences. So we put a slash n in a string that will be substituted with a new line character. So every argument is separated with a new line. You can see that 10, 20, 30 comes up line wise. So you can do all these things. So you can use sep is equal to decide what should be the separator between all the fields. But what if I want to change the record separator? For example, I want the field separator to be, let's say this time I'm going to use comma, I'm not comma, let's say, yeah, I'll use comma like this. But at the end, I don't want to add a new line. I want the next print function's output to come up on the same line. Then I can also pass another keyword argument, end is equal to empty string. When I say end is equal to empty string, that means do not have any end separator or record separator. Sep is field separator. Separator is end is at the end, right? And yes, when you're passing keyword arguments, you can change the order. You can say end is equal to empty string followed by sep is equal to comma. The order does not matter. The keyword matters, right? That's very important. At this moment, I should tell you, whenever you're reading functions or learning functions, you want to know what arguments these functions support. If you're using something like VS Code, this happens all the time. And for me, it's annoying. I just press escape and I see that out of instinct. See, the moment that I print, it's sort of auto completed here. The moment I open parenthesis, you see this. The moment you put a star values here in the syntax grammar, they mean to say that you can have multiple arguments, multiple positional arguments, comma separated multiple arguments. It's also called as variadic or variable arity. These are the terms that people now will use. But yeah, it's like variable arguments. You can have one argument, two argument, three argument. You can pass any number of arguments to print, separated by comma. That's what the star values actually signifies. Right? The star followed by the asterisk followed by this word signifies variable arguments. You can also see sep must be a string or none, which is equal to, by default, it's a space, which means you can pass a keyword argument called sep is equal to, if you don't pass this keyword argument, the default is assumed to be a space. That's what syntax grammar is trying to tell you here. And end, which also has to be a string or none, whose default argument is new line. The default end delimiter is a new line, but you can change it to any other string of your choice. And here you have the complete details. There are also other parameters like flush and there should be file. Yeah, here it is, file and flush. I'll talk about these things later stage. Okay, for now it may not be wise because I need to talk about file IO a bit, and then I can talk about what is file is equal to parameter. So you can actually use it to write to a file if you know how to open a file for writing. And they are documented right here. So you can see the complete documentation is provided. This is a good thing with VS Code because you have all these IntelliSense that comes up. You know, person like me who is an old timer who's been using Vim all through, we don't really look at this. We have it here, right? So that's what you should aim at. So all the built-in functions, how they work, you should practice Python to a level where all of these are in here and you don't have to depend on autocomplete. That's what makes you a core Pythonista. If you want to say you're a Pythonista, at least the core Python concepts. That's all the built-in functions, not all, I mean, majority of the built-in functions, I would say, maybe about 60, 70 built-in functions. That's the majority. And all the built-in types, how to use them, all the syntax, grammar, everything must be here. It shouldn't be depending on IntelliSense. I would not say the same when I talk about other languages. But Python is intended to be like that. It's designed in such a way that it can fit into your brain very quick. It can map to your brain very well, very quickly. I've been dabbling with other languages like Ruby and Java and, in the early years, C++, which I've totally forgotten now. That's what I keep telling. But though I tried with so many other languages, when I dabble with some language like Java or Ruby, every now and then, I need that documentation somewhere, reference guide somewhere to look at what I can do, what methods are available, and what functions are available. Because you cannot fit everything to a brain. Python, they have made it so refined that as you start using it, you don't have to depend on IntelliSense or documentation. Magically your brain will recollect it. An average human being can remember 10 names to maybe 12 names, right? I mean, if I ask you name your friends or name 12 friends of yours, I think it's not very difficult for most people to remember 12 friends, assuming you have 12 friends, right? So if I say I have like 100 friends, I don't think I can recollect all the 100 friends until I have superhuman power out of 70, right? It's difficult. I don't remember. It takes more time. But last 10 to 20, it's not very difficult. And if you look at the Python's syntax, of how much you have to memorize and all that, it falls in that particular sweet spot. You will start seeing that when I talk about methods, especially with a list and dictionary and all. Okay, you'll realize that. Anyways, I talked about print function. And yes, if you want to get help for any function in VS Code, you get it this way. But if you're not using VS Code, if you're using Jupyter Notebook or IPython, there's another trick. See, I'll show you. If I use the standard Python environment, you can always use help of print like this. You get the same syntax, grammar. You get all these details. Help can be passed with any argument. It could be a function, a built-in function. Suppose it's a help of input. You get information about input. This works on all the standard Python shells. But if you're using IPython, it's a little more convenient. If you use IPython instead of standard Python shell, you can try, instead of typing help of print, you can just put a print question mark like this. It's a shortcut. Or you can also try input question mark. Int question mark. It says int of x returns an integer. Int of x comma base is equal to 10 also returns an integer, and base is equal to, it tells you what it means, what all you can pass, right? Gives you all the details and some examples. So this is how we can get quick help for any data, that any functions, I would say, or data types, for example, right? So you can get quick help over here. If you're using the old school Jupyter Notebook, there's a trick using Shift tab. Shift tab. I will quickly show you that. If I just type Jupyter Notebook, it has to open a default web browser. I think it did open. Yes. Let me just create a new dummy Python notebook here. And here, if I just type, let's say, print, open parenthesis, you won't get any autocomplete in this browser interface. But when you open parenthesis for a function, you can actually type Shift tab. Well, the Shift tab key. You get this. You get a nice tooltip. You press Shift tab one more time, it's 2 times like this. It drills it down and shows you more details, which you can scroll through. You get a quick tooltip. Shift tab once, quick tooltip. Shift tab another time, you get more detailed information. It's a nice hint, and you can look at it and you can type it and say, I don't know what it is. It's called sep is equal to end is equal to what it is. Shift tab, I can find out. Sep is equal to end is equal to file is equal to flash is equal to. It's pretty straightforward, isn't it? So you can always get help when you need, when you're working in the environment in Python very easily. It's not just in the IDEs, you can get it almost everywhere. In the Python prompt, also you can get it. IPython, use a question mark. You can also use question mark even here. I mean, that'll work. But try maybe print question mark in this case and say control enter. It opens up in a separate box here, which is like a pop-up. You need to close it, right? So that's what you should know about getting help for most of the functions. Some of you might ask me, what are the built-in functions in Python? What functions exist in Python? There are 2 ways to find out. One is the official documentation. First, I'll show you the official documentation of Python this time. If you just go to docs.python.org, this is the official documentation for Python that's hosted in python.org. So when you go to this official documentation, I recommend you to read the tutorial when you can. And most people look for so many different documents and so many different other articles and books on Python. But you know what I recommend always? If you want to be proficient in Python, just finish the tutorial. That should suffice in most cases. And after that, whatever you learn in books and other things would be extraneous details, like say, how do you do all the acrobatics in Python, right? So to know the syntax grammar, most of the concepts I'm covering are all there right in tutorial, and sometimes it's more elaborate and more detailed in the tutorial. And the good thing is that it's very easily readable for newbies. The only problem is most people don't have time to read it, but that's the big challenge today. Everybody wants to master programming in 10 hours or 1 hour or 2 days and 10 days and all that. And trust me, it doesn't work that way. You cannot master programming in 10 days. Take it from me. Mastering programming in 10 days is like mastering karate or kung fu in 10 days. Imagine becoming a black belt from zero to black belt in 10 days in karate or kung fu. Can you? You must be superhuman to do that. Imagine learning how to drive a car and becoming an avid motocross expert in 10 days. You need more practice, more and more practice. The more practice you have, the more better and proficient you become. So most people who claim to have mastered Python in 10 days, either they're lying or they might be telling you, thinking that they have mastered it. Well, they might just be knowing very thin layer of it. How much time does it take to master Python? I would not say time. I would rather put it this way. Compared to other languages, you can master Python quicker. That much I can tell you. But it all depends on how many lines of code you can proficiently write. If you've written any code which goes all the way to, like, say, about 1,000 lines, that's a ballpark number. I don't think that will be the accurate picture, but I'm just giving you a hint. If you're able to write 1,000 lines of Python code, I'm not trying to say thousand lines of print hello world, 1,000 lines of different features and all the features of Python, all the idioms of Python embodied in that 1,000 lines. If you're able to write that, I think you're going to become very fluent in Python, at least core Python. That's what I would say. I say 1,000 to 2,000, whatever the number is. That's around that number, right? Some people might say, by the time I wrote 500 lines, I'm good enough. Yeah. It all depends on what's your comfort, at what level you find yourself comfortable, right? So it depends on that. So yes, go to the tutorial, and the good thing is that the tutorials are very, very accessible. Try out all these exercises. I mean, not exercise, all these things, right? Every time they show you a triple greater than prompt and try out something, try it out and see what happens and see what changes you can make to whatever alterations you can make or explore, right? So you can try all these things out. Very elaborate and very detailed. And apart from the tutorial, you don't stop there. You need to go to the library reference. And in the library reference, there are a lot of these first few chapters are definitely worth reading to the finish. Not to the entire end. You can't. It's too much of documentation here. But I would say at least the built-in types, built-in functions, built-in constants, built-in types. Finish them. Built-in functions. Here's where all the built-in functions are listed. Actually, if you look at it, it's in one screen full, then it's not difficult. By now, I can tell you that you would know about 20 functions, roughly, maybe 20, close to it. Print, input, two functions we learned, and so-called functions like, I talked about int, float, complex, bool, tuple, list, set, dict. They're all the area. They're all type constructors, right? Oh, we learned hex, awk, bin. We learned round function. So we have learned sizable number of functions and constructs from here. So there are much more. So once you know these very well, you know the core Python language. Beyond that, you just need to know a little bit of standard library and how to apply different logical thinking is what is there. So that comes with a lot of practicing. I'll give you a lot of exercises, a lot of examples in the coming sessions. Once we finish this first layer, right? The next coming sessions will try out a lot of examples where I will show you how to solve a problem and what trick to use and so on. So more you read code and more you try out in your own way, you get better at it, right? All right then. So in this session, I think to summarize, I told you about type construction and how do you convert between types, not just with int, float, complex, but it works with all data types, right? So you can construct most data types with their compatible types, and you can create a string from just about any object by using str of the object that provides string representation. And I told you how to use a print function, and I talked about two keyword arguments print function, sep is equal to, end is equal to. Try these things out and let me know if you have any queries or any questions. Please post them on comments. And as usual, do like, share, subscribe. I need to keep saying this, right? Yeah, I want to see more people watching this video, hopefully. So yeah, hopefully it benefits someone. Thank you very much. So hopefully meet you in the next one.